everybody, how's it going? My name is Liz and welcome to the Community Conversation Series. This is an opportunity to discuss technical developments with the internet computer and upcoming proposals to the roadmap. So today we have Engineering Manager Akhi Singhania here to talk about increased canister storage. So currently the limit of one canister is 4 gigabytes and the limit of a subnet is 300 gigabytes. So there is an upcoming proposal to increase the storage limit of the canister. So without further ado, I will hand it over to Akhi. Feel free to take it away.
Thank you very much, Liz. I'll start by sharing my screen. All right. I hope everyone can see my screen. Right. Liz already did an introduction, so I'll skip the initial slide. So as Liz mentioned, currently a canister is limited to 4 gigs of useful storage. The reason for that is currently a canister has access to 4 gigabytes of Wasm heap and 4 gigs of stable storage. But anytime you upgrade a canister, the Wasm heap is cleared. So as long as you're writing a canister that can be upgraded or should be upgradable, you effectively only have 4 gigs of useful storage on the canister. Before we get into a bit of discussion on what are the proposed changes and so on, let's just quickly cover the background on how did we end up here. So way back before launch, when we were working on figuring out how to build stable memory, what it should look like, what should its capacity be, we were inspired by 2 specific WebAssembly proposals, which are 64-bit Wasm 64-bit Wasm and multiple memories. When we were working on stable memory, both of these proposals were still in very early stages and no mainstream Wasm engine supported them yet. So what we wanted to build, we wanted to make sure that we do not deviate too much from these proposals so that we can still, whenever these proposals made it into the mainstream, we can still incorporate them or with them with very little effort. So with that in mind, we said we will work with Wasm 32, which means that we will limit our stable memory to 4 gigabytes. And that is how we ended up with 4 gigs of Wasm heap and 4 gigs of stable storage. So, this has a bit of a problem, right? You have lots of applications for which 4 gigs of storage could be just plenty of storage and they could scale just fine with that. But after we have talked to a lot of external developers and also our internal experiences by building a lot of canisters, what we have realized is in many cases, this 4 gigs of storage actually is quite limiting. And what we also realized is that the current capacity of a single subnet, which is around 300 gigs, is actually quite sufficient for quite a while, right? So if I could somehow let my canister or my application grow to 300 gigs, I can scale out I can support a lot of users, I can support a lot of data, and I do not need to grow out beyond that in the short-term future. Of course, in the long term, when I'm writing internet scale applications, then I need to, of course, go beyond that as well. The other thing we realized is that sharding applications into multiple canisters produces a lot of complexity and impacts performance. So when you shard your applications into multiple canisters, now you need to send messages between these canisters to get the relevant data. You have to write a lot of asynchronous code. You have to worry about intermediate states being committed and being observable and all of these things. So, and it can become very tricky and very error prone. So what we realized is that if we somehow allow a single canister to potentially scale to the capacity of the entire subnet, that would make writing applications that can use up to 300 gigs or whatever the capacity of the subnet is much simpler to achieve, and also keep the performance impact to a minimal, because now you don't need to send messages to other canisters and so on to get the data that you want. So with that in mind, we decided an approach to take would be to simply extend the stable memory. And the way to do that would be to change the stable memory API from 32 bits to 64 bits. And this would allow canisters to then address a lot more storage than it currently can. And definitely it can address the entire storage of the entire subnet. So here's the proposed API that we have right now. And I've highlighted in green the changes that we want to make. I do want to note that we are not planning on breaking old canisters here. So we would keep both APIs. And so we would just be introducing the 64-bit API, and we would be keeping the 32-bit API so that we do not actually break any existing canisters. So with this API, if this proposal and this API was merged into production and was available, then this is how we expect canisters to actually do their work in production. So when a canister receives a message and it starts executing it, it will first have to figure out where in stable memory the relevant block of data lives that it needs to work on. It will then copy that data from stable memory to the Wasm heap. And this copy is necessary because there are no native Wasm instructions that let you work on the stable memory. So you have to copy this data into Wasm heap so that you can actually make modifications to it. And then the canister will actually operate on the data, make whatever changes it needs to. And finally, once the data has been modified and the canister is happy with it, it will have to write the modifications back to stable memory. As some of you can already suspect or guess, this will introduce some potential footguns. So one of the problems is that each canister, it has an upper limit on how long a message can execute for. And if the canister hits this limit, then the message execution is declared as failed and all the changes it made are rolled back. So in this example, in this operation that I described, it is possible that after the canister has done a bulk copy of the data from stable memory to heap, made changes to it, but before it manages to write the data back to stable memory, it hits the message execution limit, and the message execution is declared as failed, and everything is rolled back. A similar footgun actually already exists with canister upgrades. When you're upgrading a canister, the Wasm heap of the canister is wiped clean. So when a canister is being upgraded, what the canister is supposed to do is, before the upgrade can proceed, in the pre-upgrade hook, it should serialize all the data from its Wasm heap to stable memory that it wants to keep after the upgrade. But it is possible that if the canister has accumulated a lot of state in its Wasm heap, that just serializing that entire data to stable memory can cause it to hit the message execution limit of the pre-upgrade hook. And if a canister cannot serialize its entire state within the execution limit, then the pre-upgrade hook will fail and it will effectively become impossible to upgrade this canister. So these footguns, the team is aware of, and we're actively working on solutions for these. And the plan here is to build out better scalable storage that are upgrade safe in iterations. And as we come up with new proposals to address these footguns, we will be reaching out to community for their feedback and to see what they think and how we should move forward. So like I mentioned before, the current rollout plan for this API is to retain both 32-bit API and to introduce a 64-bit API for backwards compatibility. And if a canister is using up to 4 gigs of stable storage, it can use either of the two APIs because both of them work. But once the stable memory size exceeds the 4 gig limit, then only the 64-bit API will be allowed. And trying to use the 32-bit API at that point will result in a trap. And just so we can roll things out into production gradually, no matter how much testing we do, to minimize the risk of potential bugs, in the initial rollout, we will cap the stable memory to 8 gigs. And once we gain confidence with the API, the implementation, and it's the stability of the implementation and production, we will gradually increase this limit. And finally, we want to work more closely with the community in helping us refine and define what the API should be. So with that in mind, we are going to ask the community to treat this API as experimental for now. And we will ask the community for feedback on the API to help us refine it. And in case we come up with improvements on the API and we decide to make changes to it, we would potentially be breaking canisters that are already using it. So we ask the community not to use the API in any critical canisters already. This will give us the flexibility to change the API without leaving a lot of cruft for backwards compatibility in the IC API. The other thing I would like to mention at this point, which did not make it into the slides, and that Diego has mentioned in the forum and on Reddit, is that tomorrow we will be releasing a draft proposal that will be outlining the details of this API, a draft NNS proposal. On September 1st, it will be official NNS proposal that will be released, and the community will be asked to vote on it. The proposal will run till September 3rd, and only if the voting says that, only if the proposal passes will we actually work on the API and we will actually release the API to production. Otherwise, we will go back to the drawing board. We will ask the community for feedback and try to come up with other approaches to solve this problem. With that being said, I would like to conclude. What I discussed is a simple fix to allow canisters to address more stable memory and allow them to scale to the capacity of a single subnet. And there's a lot of progress happening there's a lot of discussion happening on this on the forum and on Reddit. So I encourage all of you to check that out. And I thank you everyone for listening.
Cool. Thank you so much, Akhi, for that. So there are a couple of questions that have been coming through in both Q&A and the chat. And everybody feel free to continue adding your questions to the Q&A list and typing your questions out in the chat. So Akhi, I know that you had touched upon this question already, but just to make it crystal clear for people who are watching this call and also in the future, for people who are watching on YouTube, what exactly is the ETA for the rollout of increased canister storage?
Sure. So tomorrow we will post the draft proposal to the community to review this design and this API. On September 1st, it will be an official NNS proposal where all community members will be allowed to vote on it. And on September 3rd, the proposal will expire. And let's say if the proposal passes, then shortly after that, we will be enabling the API in production. So the bulk of the implementation of the API is already done. And we have just not enabled the final, we have not pushed the final changes to production that will actually allow canisters to start using it. And we're waiting to get the go-ahead from the community to do that. So if the proposal passes on September 3rd, probably the next time we upgrade subnets after that, the API should be enabled.
Right. So I think it's important to reiterate something that Akhi had just said. So essentially, the Internet Computer Network cannot be successful unless the community all participates and it's community governed. So even though the code is ready from our end, we still need to make sure that this is the direction that the community wants to move in. So if you're interested in participating in this governance decision, you can check out the post on forum.dfinity.org. Thanks, Akhi. So next question. I know this was answered in the chat, but for the benefit of people who will be watching on YouTube thereafter, is the 300 gigabyte limit per subnet capacity for a single canister or for all of them shared?
Currently, it is for all of them shared. So all the canisters on the subnet will be using a piece of that. The other nuance that I want to mention there is that currently, this is just a current subnet limit of a given subnet. In future, we will have subnets that can support even more storage. So this 300 gigs of limit is by no means set in stone, and we have ways of extending this, and there are a number of things we can do in the future to allow a subnet to support even larger amount of storage.
Cool, thank you, Akhi. So next question, which is an interesting one. Does increased storage per canister mean increased amount of cycles needed per canister?
Yes, so a canister has to pay for all the data that it has uploaded to the IC, and it has to pay for that at regular cadences. I forgot, I do not recall off the top of my head what the current fees are, but this is documented in the source code of the Internet Computer. And so the more data a canister is using, the more storage it has, the more it has to pay.
Cool. Thank you, Akhi. So is the 300 gigabyte limit a hard limit on total subnet storage? Or if we theoretically were to add more nodes, could it increase the limit of the subnet?
Adding more nodes to a subnet will not increase the limit because all nodes in a subnet are doing replicated execution. The way to increase storage limit would be to add more power. One way to do that would be to add more powerful nodes with larger disks and more memory. The other way to increase it would be to improve the performance and the to make improvements on the IC itself, so that it uses less storage and it can store the canister data more efficiently. And we will be working on both of these paths in the future. So we will be introducing different subnets with different hardware that can support larger, with more storage or bigger disks. And we will be making improvements to the IC so that they become more efficient in storing canister data. So both of these will help us increase the storage of the subnet.
Great, thank you, Akhi. So next question, how do you make sure a canister doesn't monopolize the available storage within a subnet?
So currently we set the upper limit on how much storage a canister can use to 8 gigs. And in the initial rollout of this feature, we will increase that total amount to 12 gigs. And as we let canisters use more and more stable memory, we can, in theory, let canisters use all of it. And if we want to prevent that, we have to put a cap on how much storage a given canister can use. And if a canister wanted to use all of the storage on a subnet, as long as it's willing to pay for it, that can be fine. But then we enter the realm of dedicated subnets. So if you want to work on an application where you know you need the entire storage of the subnet, you want to monopolize the entire subnet, then we can do dedicated subnets for your application. And then no other developer will be allowed to create canisters on that subnet, and you can use the entire subnet for yourself.
Great, thanks, Akhi. So next question, is the per message execution limit a time limit or a cycle limit?
It's a Wasm instructions limit. So in order to keep the replicated execution on all the nodes of the subnet, in order to keep it deterministic, we put an upper limit on how many Wasm instructions a given message execution can execute. And once that many number of Wasm instructions have been executed, we trap the execution and we declare it as failed.
Great, thank you, Akhi. So next question, will this API be available for both Motoko as well as Rust?
I believe so. We are working actively with the Rust CDK, and Motoko will also, eventually Motoko will also make this API available. I do not know what the ETA on that is though.
Okay, thank you. So a question from the community. So to clarify, the API will be enabled with another NNS proposal. So there are at least 2 NNS proposals.
Yes, so the first NNS proposal will not actually will not introduce any code changes to the IC. It will just be to get the community feedback. And if that proposal succeeds, then in a subsequent proposal, we would upgrade the subnets on the IC to actually enable the API.
Well, thank you, Akhi. So next question, will the internet computer be able to dynamically split subnets as multiple canisters head toward using up all subnet memory? What exactly happens to smaller canisters as one canister or a few start to monopolize the memory of a subnet?
So subnet splitting is something on our roadmap, and Dom has talked about it a number of times, and he's very passionate about this idea. It is something that we would like to work on. There are a lot of subtleties and corner cases in in making that a reality. But this would be one way to handle the scenario where canisters on a subnet become so active or start to monopolize the entire subnet. Then one way to handle that scenario would be to split the subnet into multiple subnets. Well, first you would need to add a bunch more nodes to the subnet, and then you can split the subnet into two, with half the nodes handling one subnet and the other half handling the other half. And you would take the set of canisters and put half of them in one and the other half in the other one. But this introduces a lot of subtleties, a lot of corner cases, but this would be one way for us to scale out a subnet as it becomes, as the number of canisters on it increases, or the amount of activity on that the canisters are doing on the subnet increases to the point where a single subnet cannot handle it anymore.
Cool, thank you, Akhi. So the next one is a rather interesting question. So with increased canister storage, are there any sort of second order implications that might not be immediately obvious? So for example, does increased canister capacity affect decentralization or security in any way?
The main impact that we have identified is what I covered in the slides here. In particular, this introduction of this footgun, where if you are working with very large data sets, you might hit the message execution limit, and you might not be able to make the changes that you wanted to do in the execution limit that you have. Beyond that, I'm not aware of any decentralization impact or security impact of it. So I guess one way, maybe an argument can be made that having a single canister with 300 gigs of storage is more centralized than having a bunch of canisters with a small with fewer storage. But if all of these small canisters are controlled by the same entity or the same actor, I'm not sure if there is much difference there in between centralized and decentralized approaches.
Great, thank you, Akhi. So next question, we have a lot of questions from the crowd today, which is wonderful. Keep it coming. Can developers pick which subnet to deploy their canister on? For example, if a subnet has only 20 gigabytes available, stable memory, and another has 100 gigabytes, then maybe one person would rather choose to deploy on the 100 gigabyte subnet.
Yes, unfortunately, currently, we have not come up with a good way to expose this ability to developers. And I would very much love to hear ideas from the community on how we could enable this. There have been some ideas in the organization that we have discussed, and this is something in our roadmap that we want to handle. So yes, I would love to expose this ability to the developers, but unfortunately, this does not exist yet.
Okay, thank you, Akhi. So next question. Will canisters using more than 4 gigabytes have a larger per byte cost in cycles per gigabyte than canisters using less than 4 gigabytes, say due to increased processor power needed to do paging or whatever?
No, the per byte cost does not change. It is not a function of how much data the canister is using.
Cool. So, that actually is the end of the questions that have been submitted so far in Q&A, as well as in the chat. So if anybody has any burning questions for Akhi or myself or any of the DFINITY team members on the call, definitely feel free to drop them in the chat or Q&A now. I'll give everyone just like a couple of seconds if they want to add anything. But generally, this was a really, really great talk, Akhi. Thank you so much. This is something that the community has been asking for a really long time. So assuming that the proposal is successful, I myself am very curious to see how that'll impact developers and how they build applications upon the internet computer. So, okay, I don't think I see additional questions in the chat or Q&A. So we can end here for now. Thank you everyone for your time on this call. Thank you so much to Akhi. If you want to be able to continue the conversation, go ahead and go to forum.dfinity.org to chat with like-minded participants. So thanks everyone, and we'll see you at the next community conversations. Bye.